Hi. So in this video, we're going to talk about alternative vector journeys, and I'm fully going to give you a disclaimer at the start of this video. This has been potentially the video I've been most apprehensive about making because of how we're doing it online. I would normally be using a lot of smartboard usage and having printouts in class to do this because it's really quite a visual and descriptive way of thinking about maths. So bear with me with this and try your best. And as a different way of doing this, I'm simply doing from the textbook pages the example question and then question one. Because then hopefully you can see the example in the book, you can compare it to the book and then compare it to your own video, your own thinking, and then the video. And ultimately, once we're back in school, hopefully soon, I'll be able to explain this maybe better. So, in terms of vectors, all that really matters is the starting point and the finishing point. Okay, so you can describe a series of journeys by different journeys added up together. Okay, so what it's saying is find in terms, that's not very good handwriting, in terms of u, vector u, and vector v, the vectors DC, AC, AD, and BM. So it's us knowing that the vector A to B is the vector u and the vector B to C is the vector v. We can describe all these other journeys as vectors u and v by just continuing the path. So as long as you start and end, the vectors all sum up to give the correct answer, which hopefully I will explain better when I show you this one. Okay? So I need vector DC, okay, which is this journey. What it tells you here is DC is 2 ABs. Okay, so that is twice the distance of vector AB. And since it's parallel, and then it's twice the distance, all we need to do to get DC is multiply AB by 2. And since AB is the vector u, it's just going to be 2u. And that is it. It is quite conceptual. It's quite hard to see as well if it's maybe over a video, but hopefully we'll do our best. Do another one. We're doing the vector AC. So I need to go from there to there. Okay. So what I do is I start at that vector A and I just go a different direction. And as long as I end up at C and I get the correct vectors, then it will give me the same answer. So if you see, I'm going along there and along there. Starting point's the same, finishing point's the same. So really, vector AC is actually just vector along AB and along BC. And we can see that we know them. It's U and V. So it is just U plus V. Do another one. Doing the vector AD. So it's getting a bit more complicated. But again, I can start at A and end up at D. Okay? So there's two ways of thinking of this. We could go right along here, along, and then along, and then along. Or we could actually go along this new vector we just found, but then essentially that is the same as we found out that U and V are actually A to C. So we do end up with the same answer. So we could think of it as going along U, and then along V, and this is where it gets a bit more tricky. The vector DC is 2u, but I'm not going from D to C, I'm going from C to D, I'm doing the reverse journey. So it is plus negative 2u, okay? Because I'm going in the wrong direction along the vector. And so u minus 2u is negative u. So the vector A to D is negative u plus v. Last one in this question, it is the vector B to M. Now it says here that M is the midpoint of BC. So if that journey is V, then the vector journey halfway is just going to be half V. Okay, so you can multiply them just like we did here where we multiplied it by 2. We can multiply it by a fraction. Okay, so I'm going to do another one. Find the following vectors in terms of u and v. Now this is a parallelogram, so that's helpful because we know that some of these vectors are going to be parallel and therefore the same. For example, QR, which is the first question, we can see straight away that that is parallel to this vector and it's going in the right direction. So QR is actually just the same vector as PS. Not negative, it's just V. Because they're the same vector. And then again, SR is just PQ because they're parallel and the same size, magnitude even. So that's just a vector U. PR, there's two different ways of doing this. You could go along and across, up and across, or across and up, but ultimately it gets the same answer because if you go along, it's U plus what we just discovered is V. Or if you went up and across, it would be V plus U, and that's the same answer. QS, so it's getting a bit more complicated. So we could go Q to P, P to S, and then hopefully realize that we're going against the arrow, so it's going to be negative U plus V. So that one flips direction, but that one stays the same. P to M. So M is the midpoint of PR. We know that PR is U plus V. So PM is actually just going to be a half U plus V, which you could leave inside with the brackets like that, or you could break out the brackets and get that. Last one, S to M. There's different ways we could do this. We could think of it as an alternative journey, S to P, P to M, and then so it would be negative V, add whatever PM was, which was this. What I'm actually going to do is, we learned in part D that QS is negative U plus V. So we've got that whole journey as negative U plus V, but now we're going in the reverse direction, but only halfway. So it's going to be a half times this, but also times by -1. So it's actually going to be negative a half times negative U plus V, which will break out to be a half U minus a half V. Okay, but we'd have got there the same way if we'd done negative V plus a half U plus a half V. It would have come out with the same answer. Okay, so that is alternate vector journeys. Okay, so maybe you watch this one a few times, or maybe I'm completely wrong and you've all understood this, hopefully. But if not, don't worry about it, because this is a very different way of me teaching this specific type of topic. But let me know by email or anything if you are finding this difficult, and I totally understand if you are. Okay.